working as a principal researcher as a Brainful Fellow invited scientist at Inha University, South Korea. And I completed my PhD in material science and engineering from National Taiwan University of Science and Technology, Taiwan. And I completed my master's from Sri Padmavati Mahila Viswavidyalayam, Tirupati, Andhra Pradesh. And I completed my bachelor's from Sri Venkateshwara University, Tirupati, Andhra Pradesh. And after my master's, I joined as a assistant researcher at Delhi University of Delhi. And coming to my publications profile, up to now, I published 40 publications. In this, uh, 28 are Q1 and 9 are Q2 and 3 are Q3. And the total cumulative impact factor is 416. And then average impact factor is 10.4. And up to now, I have 12 lead author publications. And I have 4 granted patents in this. Two are USA and 2 Taiwan patents. And the now currently 2 patents are under review, and I have 4 book chapters. Um, and then up to now, I have 3,361 citations, and my H index is 28. And this all is my publication profile. And these are my Q1 papers and corresponding other papers. Coming to my patents, 2 USA patents and 2 Taiwan patents. In this first USA patent on ultra thin triboelectric nanogenerator and applications theory. And in this, we mentioned and we prepared a very thin 5 micrometer thickness of porous polyurethane membrane, and with a very good and simple fabrication methods. And these we applied for a patent, and finally successfully the patent grant has approved. uh, Now we are trying to reach a company to fabricate in the industrial scale. And this is my second US patent. And this one is the title of this patent is cigarette filter triboelectric nanogenerator and the manufacturing method for the same. And this patent is talking about waste to energy topic. Uh, we we collected some cigarette filter waste material, and with this we created some electricity. And with this topic we get a good patent. and and 2 more Taiwan patents are there with the similar and a little bit more novelty on the patents. And coming to up to now, I have 2 individual fellowships with the funding amount of 1.67 crores INR. And in this, I successfully completed one fellowship, and one more is ongoing fellowship this month. And like next month, I'm going to finish successfully this fellowship also. And in addition to that, I have an external funded research grant also as a principal investigator. In this, there is no any co-PIs. I am only the principal investigator. And this one is funded by National Research Foundation of Korea. And the funded amount around 1.167 crores INR. The total 3 grants total fund is the amount is 2.8 crores. And coming to uh, I also I have selected as a early career editorial board member in Resultant Engineering Journal, which is sorry. which is 6.6 impact factor, Q1 journal. And also I have selected as a early career editorial board member in Chemical Engineering Journal recently, and which is 13.2 impact factor. And this is also Q1 journal. And today's my topic outline is I want to discuss about energy harvesting, some introduction, and also fundamentals of technologies and mechanical energy harvesting, and that's about my research papers. And after that, I will discuss about the hydrogen energy introduction and coupling of triboelectric nanogenerator with electrochemical water splitting. I will discuss about this. And finally, my experimental results and some challenges and opportunities and future research roadmap I will discuss in this session. Now, in my topic, the future of self-powered sustainable energy, the triboelectric nanogenerator and hydrogen energy, how we are going to combine and finally we will produce hydrogen energy. In this session, I will discuss very deeply. Um, Actually, I am thrilled to be here to discuss a truly transformative concept, that is triboelectric nanogenerator and hydrogen energy. As you can see this slide, the future energy landscape will be decentralized and green, and we are moving towards a system where we not only generate a clean energy, but we also create the mechanism for self-sustainability. And these tanks, triboelectric nanogenerators, are a key here. The harvest waste mechanical energy from vibrations, wind, and even water motion to power sensors, monitoring equipment, and crucial to enhance the efficiency for hydrogen production itself. The leading to a true sustainable, self-powered sustainable energy system. This combined approach is what we believe will unlock the next era of clean power. And why hydrogen energy? Now, why hydrogen energy is central piece of the vision. The answer lies in two critical advantages over the traditional energy sources and even current battery-based systems. First, I will talk about the decarbonization. Hydrogen is a uh, critical key to achieving a net zero future. When used in the fuel cells, it also byproduct is pure water. This fact makes the ideal substitution for fossil fuels uh, in what we called the hard to absorb and sector areas like heavy industry and steel production and long transport, where electrification alone is challenging. I want to discuss about the energy storage also. This is most important role is the energy storage. Energy storage is having the renewable energies. Solar and wind is intermediate. It's available when the sun shines or the wind blows, but not always when we need it. Unlike electricity, hydrogen can be stored in massive quantities for long periods, acting as a versatile. Sensational energy carriers that solves the interpreting problem and ensuring grid stability year around. And uh, actually, in this slide, when we talk about the hydrogen, it's essential to understand that not all hydrogen is created equal. The industries use a color spectrum to clarify hydrogen based on its source and its carbon footprint. This table summarizes the key players. Uh, the actually green hydrogen. This is the goal. Um, to produce through electrolysis of water using 100% renewable energy like solar or wind. It has a zero emissions and it is most sustainable choice. Our focus on self-powered systems is primarily aimed at scaling green hydrogen production. And and then next one is blue hydrogen. This blue hydrogen also a natural gas, but it is utilize the carbon capture storage. This significantly lower its carbon impact, making it a critical bridge technologies. And coming to green hydrogen, this is cheapest and most common from the today derived from the natural gas using steam methane reforming. Crucially, it result in high CO2 emissions, making it unsustainable for our long-term goals. Um, then pink hydrogen. This pink hydrogen is a notable clean alternative product produced by electrolysis using nuclear power, which also results in a zero carbon emissions. But in our case, we are mainly focusing on renewable energy, where hydrogen useful. Hydrogen utility instead limited in one area isn't it's a versatile molecule that can fundamentally transfer multiple sectors of our global economy. We can divide its main application into different categories. One is transportation, metal and steel production, and biofuel upgrading, and synthetic oil and fuel, and pharmaceutical, domestic and commercial heating infrastructures, and chemical industries, and electrical grid station, power generation, and power plants. Here, I would like to talk about only three topics, that is transport and industry and power generation. Transport. Um, the focus the focus of here is fuel cell electronic vehicles, especially for heavy duty applications. For trains, ships, and long trucks, batteries can be too heavy or too to take a long to charge. Hydrogen offers a fast refilling and large range. In industries, this is where it the hardest emissions. Hydrogen is essential for decarbonization, steel manufacturing, ammonia production for fertilizers, and chemical refilling, all sectors that traditionally uh, really heavily on fossil fuels. Then coming to power generation, this connects back to store. Hydrogen is critical for grid balancing, essential energy storage, and providing backup power systems to support the huge influx of intermittent renewable source like a wind and solar. Global hydrogen market growth. This in this slide, I would like to talk about market. Then it's a massive and rapidly expanding market opportunity. The number speaks of themselves. Here, as global policies align with net zero goals, investment is different. Then, while the market was valued at different approximately 204 billion dollars recently, and it estimated to growth around 340 billions. It's depending on how much global decarbonization mandatories. And then first, I would like to discuss about the triboelectric nanogenerator, how this triboelectric nanogenerator is useful to generate the hydrogen energy. In this, the triboelectric nanogenerators, the triboelectric nanogenerator is the device that converts waste mechanical energy into useful electricity. Um, think of them as a ultra efficient energy scavengers. The these the mainly using the tanks can useful using two fundamental principles. That is, one is contact electrification and another one is electrostatic induction. And contact electrification means generation of surface charge when the two different materials going to contact each other and separate. And electrostatic induction means driving electron flow through the external circuit to balance the potential difference. Then only the electricity will generate. These two phenomena are very important for triboelectric nanogenerator to convert the mechanical energy into electrical energy. This is having the tank device, for especially for tank device, um, two different materials is very important. One should be a positive material and one should be a negative material. These two materials is very plays a very crucial role in the triboelectric nanogenerator device. In this device, these two materials taken with choosing the affinity of the material. And this tank device, these triboelectric nanogenerators is having a very good advantages. That is, they have a large output power relative to their size, and they are low weight, use a simple fabrication method, and crucially, they are excellent at harvesting the low frequency of energies. And in triboelectric nanogenerator, there are too many different methods are there to harvest energy. But I want to discuss here about the blue energy and wind energy and mechanical energy. These three are very important in the triboelectric nanogenerator series. And these technologies are very popular also. Coming to the blue energy, this refers to ocean wave energies. Tank can incorporated into the floating structures to convert the slow, powerful motion of waves into the electricity. This provides a vast, consistent, and currently underutilized source of clean power. And coming to the wind energy, while we have a large wind turbines, tank are perfect for harvesting wind energy at the micro scale level, and low speed environments making a renewable power generation and more distributed and localized. And these are very important for renewable energies. And coming to the mechanical energy, this is a type of motion from human motion, like every day we are walking, running, and doing some exercises. With that, also we can generate more electricity, and which is having a very low frequency structure vibrations, and these tanks can the capture the energy, and this waste energy is turned to useful power for a small electronics, or in our case we can also use it for hydrogen production. Coming to triboelectric nanogenerator, and hydrogen energy by using a water splitting method. And when these two combines, what will happen and how we are going to combine each other, we will discuss in this slide. This slide shows the elegant combination of two technologies. This is one is triboelectric nanogenerator, the another one is water splitting, that means hydrogen generation. And this is the heart of the system. We are proposing a tank powered water splitting to produce hydrogen. On the left, we can see the tank device, which generates electricity from a mechanical force represented here by a person walking over it. Um, the low frequency high uh, will capture the high voltage electricity generated by the tank, and this tank is fed directly into the electrolysis. Um, the process is simple. The current split actually when the current is passing through the wires, and when the current passes, the current split the water into hydrogen and oxygen. The hydrogen at the cathode, and the oxygen at the anode. The hydrogen gas is collected and ready to be composed or stored in the hydrogen pump. Um, the structure you can see on the right, this integrated system demonstrated the concept of on-site demand based on self-powered green hydrogen production. This Then why tank and hydrogen is the best solution? In this, we will discuss. The main thing is the combination of tank powered electrolyzed the best solution for small scale and decentralized hydrogen production. It addresses the fundamental challenges of conventional electrolysis. The primary challenge of electrolysis is needed for a constant high quality AC or DC power source, typically from the electrical grid. Tank solves this by harvesting widely available but intermittent and low frequency mechanical energy that is otherwise it wasted. It's using what we have where we are. And the tank naturally produce a high voltage and low current AC output. That means this is a perfectly suitable to drive a special electrochemical cells. In many cases, this allows us to bypass complex or AC to DC power management circuits, simplify the system, and boosting the overall energy conversion efficiency. And then zero emission and self-powered is ultimately by using abundant mechanical energy to split water. The entire process from the energy capture to hydrogen production, it's truly zero emission and self-powered. And it creates a clean and fuel using only a clean input, a closed loop of sustainability. And then now I would like to introduce some of my triboelectric nanogenerator papers, papers. And before going to that, my my research profile is on energy harvesting through triboelectric nanogenerator towards achieving a United Nations Sustainable Development Goals. Finally, this it's about making a global impact and contributing the directly to SDGs. The advantages of tank and their integration with clean energy directly supports these three goals. Um, the first one is First one is I will talk about the SDG 7, affordable and green energy. This is by producing a cost-effective method to harvest and waste energy. We make clean hydrogen accessibility to more communities and industries. And coming to the nine, this is talking about the industry and innovation and the infrastructure. And this works drives technology innovation and creating a next generation infrastructures needed for a low carbon economy. And then I'm talking about the SDG 3, good health and well-being, by dramatically reducing the carbon emission and associated with the green production and transportation, and we improve air quality and leading to better public health outcome globally. And these three are suitable for my research profile. And now I will discuss about my PhD papers. That is waste to energy concept. In this, I'm following that three R cycle, that is recycle, reduce, and reuse. Both. First, we will recycle it, and then we will make it useful structure, and after that we will use it again and again. Then we can control the waste products to not damage the environment. In that case, we introduce cigarette filters, and these are discarded cigarette filters we collected, and after that we peel off and we cleaned with some ethanol, and after that we dried at 60 degrees centigrade. And this setup we repeated many times to clean, and after that we the cleaned cigarette filter we taken, and we prepared a very good film um, with control thickness. And after that we developed the tank device with by using the cigarette filter. Here, one side we use a cigarette filter, discarded cigarette filter, and after that, another side we used recycled materials in lab dustbin, like which are provided in means we can get in the lab. One is PVC and PTFE and PET and PP films. And these are recycled materials. And we prepared a very good tank device. With this, we turn on 44 LEDs, and also we turn on the small electronic gadgets. And by using this tank device, and also we used some waste vibrational motion to create voltage. And by with this also we can turn on small gadgets by using a small capacitor. And this is my first paper. And after that we tried, um, we collected some waste fur, and we mixed with the chitosan and prepared a very bio waste based tank device. And with this tank device also we achieved almost like 400 voltage, sorry, 400 voltage. And after that with this also we turn on 250 LEDs and very small electronic LCD, portable LCD. And these are my papers. One I published in Journal of Cleaner Production, which is having 9.8 impact factor, and also one more paper, the cigarette filter and CNT. This paper we published in Nano Energy, which is having 16.8, and also we published that. Waste bio derived chitosan with waste fur, which is published in advanced functional material, which is having 18.5. And also we recognized for top cited article, we get the certificate. And now I'm working on waste loafer plant waste, and with this I prepared a tank device, and another material is recycled moss. One side is recycled moss and another side is loafer sponge. With this I prepared a tank device, and we performed with different contact layers, and we get almost 180 voltage and 2.8 microampere current. um, we want to utilize this tank device in a vehicle parking vacancies identification, as this tank is working as a sensor, and we started to run Arduino code, and after that we started to connect three different devices to the Arduino. Uh, Here the tank device is working as a sensor. When we are touching the tank device, it started to blink the red light, and after that it will stand up to when we again it will the tank device, when we are touching again, up to that it will the light will gloom. And with this we we prepared a smart vehicle parking vacancies identified by the LED. This application we tried and we successfully created that. um, and Coming to another paper, in this paper we fabricated the chitosan film, and using a gold edible foil. And this chitosan film is very transparent, and also it's a skin attachable film. And we used here edible gold foil to create a to as a current collector. Um, with this this film we are using to monitor the sleep. Um, this is these devices are attached in different places on the bed. When the person is moving, every movement the tank device can capture, and it will record each and every signal to check their sleep, abnormal sleep, and to estimate the how much sleep quality the person is having. Each and everything the tank can record the signals. And after that this is the useful for to identify doctors and take care person to evaluate how much sleep the person gets, and how the good quality sleep he get. Everything we can monitor with the this tank device. This tank device is not only for harvesting energy to turn on LED and LCD. We can also use it this tank device as a monitoring for sleep and good health. As a And this thing here also we can use it for as like a sensor. um then the same device, the chitosan and gold edible foil device, we are using for a security wise also. And here we try to prepare a tank device, and this tank device I'm using for Morse code transmitters. With this we already have a Morse code A to Z alphabets. With that I'm just preparing a single dot and dash technology, and with this technology it's achieving very good results. And also we can send with this tank device we can send a SMS like a danger or emergency help risk, like that, without any external power. We can use this tank as a sensor to send a notifications in for in emergency situations. um, in this we successfully check the intensity of the light by a dot and dash. That mean it's representing a dot means it's a less intensity. It will give A and B numbering, sorry, alphabet. And then the dash means that is having a very good high intensity, which this experiments shows the ability to give uh, emergency in emergencies. We can get the notifications from this device, and this is for good for Morse code transmitters and smart healthcare applications. This tank device is very good. And also, we one more paper, we prepared a flexible PDMS and boron nitride, hexagonal boron nitride composite films. And with this, we prepared a tank device, and which is used in machine learning assisted handwriting recognition. Nowadays, we know that um, many people are making forgeries. Uh, these kind of forgeries we can easily identified by writing the signature or doing any signature on the tank device. By using this machine learning technique, we can identify easily who's the person, who is, I mean, which person is writing the signature, and the correct person we can identify very easily by using this machine learning technique. With this, we started to write the tank and different words on the tank device, and after that we gave this all the data to machine learning. And after that, we give a decision tree and gradient boosting to train the data. And finally, the AI is finding the voluntary one or voluntary two or voluntary three, which one write that tank device name, or just finally it's 89 sorry 93% accuracy is following that um, AI. And sorry, and one more paper, we prepared a MOS2 petal decorated on palm fibers. This tank device we are using for a smart study room touch sensor application. In this also, we try to prepare a tank device, and that is used in the touch sensor for smart study room. And we successfully prepared a tank device as a sensor, and we clearly shown in this application this tank device is useful as a sensor for smart study room. And this tank device is harvesting almost 250 voltage and 5 microampere current. And also, with this tank device we can turn on LEDs and LCD. and and this is another paper. Um, in this paper, we prepared a PDMS with um, strontium bismuth ferrate. Um, by preparing a very flexible film, and with this tank device, we are we this tank device also we are using as a anti-theft alarm system. Um, the tank device is attaching on the purse or some other places, and when the thief or other person is touching to the wallet and start suddenly it started to blink the LED, and also it gave some buzzer sound. That mean the some other person is taking the purse, and immediately we will get the notification to the mobile. And this tank device is having a very good promising technology to get the notification to and also its work as a sensors. Mm, and up to now, we prepared a tank device, and finally we are using that tank device for LED glow, and also to glow the LCD, and also we used as a tank device as a sensor. But now, for the first time, we are using this tank device um, and combined with the electrolyzer to produce the hydrogen production. This in this the tank device we prepared with the laser induced graphene oxide, and this laser induced graphene oxide is using as a electric current collector. And here we used surface modified fluorinated polyimide as a positive as a negative charge, and the other side we used cellulose film, and these two we prepared as a tank device. And by using this tank device, we want to convert this tank device AC to DC. By this, for that, we use a rectifier bridge to convert AC to DC. And after that, we prepared a water splitting system. Here, the cathode we used a platinum, and anode we used um, nickel foam. And here, first I would like to explain about the tank device electrical performance. With this tank device electrical performance, we achieved 300 voltage. That means this 300 voltage is good enough to transfer the current, transfer the sorry 300 voltage and 18 microampere current. These two are very good enough to transfer the current to split water into hydrogen and oxygen. And and after that, with when the force is increasing, the voltage is increasing and current also increasing. That means the charges is easily transferring and easy to get the more voltage and more current. Under 15 Newton, it reached almost like 400 voltage, and also 25 microampere current, which means this when the force is increasing, and automatically the voltage and current will increase. This is very important to get the tank device to make a very promising tank device for making a very high voltage and to get the high efficiency. And also size matters. This device size is now we are taking 2.5 into 2.5 centimeter. If the size is increasing, automatically the voltage will increase, and the contact area when the contact area is increasing, the automatically the voltage and current will increase. This is very important to get very faster electrolyzer and more hydrogen production. And this device is having a very good stability. Up to 10,000 cycles we checked, and it is having a very good stability, and also a very good power density we achieved with this tank device. It is almost like 9 watts per meter square, which is more enough to get and turn on this kind of electrolyzers. Even we can charge our mobiles, and with this power density we can charge our mobiles and small electronic gadgets. And and then, coming to tank plus hydrogen production, um, we connected tank device directly to the rectifier, which mean we are not using any external power circuits. We are using here a tank device as a power supply. We are not using any outside powers. And this tank device directly we are connecting to the rectifier. This tank device will produce more voltage, and this voltage will help to run the electrolyzer. Um, Here I will show you the video. In this video, we can clearly see the bubbles are forming on the cathode and anode, which directly connected with the bridge rectifier. This is the bridge rectifier, and we are giving a tank device. This is the tank device, and we are giving the force, 10 Newton force on the tank device, and it is directly coming to the bridge rectifier uh, to to form the bubbles on the electrodes and cathode and anode, and which confirms that the hydrogen is producing um, the hydrogen is producing. Here we are in this experiment we utilized 100 microfarad capacitor to make the hydrogen production. And coming to the challenges and future roadmap, and this tank device is having very high voltage, but this is having very low current. This translates to a low hydrogen production rate, and we need to focus on the device engineering to dramatically boost the current density of the tank. And for this we want to prepare a new materials, and also we want to prepare a advanced stacking designs to achieve commercial very good hydrogen output volumes. Um, in this in this, we can also prepare a different tank device, like multiple tank device to harvest more energy. And coming to power management, see, our current power management systems is very simple. And in this paper, we are using rectifiers and capacitors. Normally, in future, we can also develop a high efficiency and customized DC-DC converters, which can help to minimize the energy loss. And then coming to durability and stability in real world environment, to be this harsh environment like ocean and blue energy, it's having a high vibration industrial settings. Tank device must demonstrate the long-term robustness and water resistance and mechanical stability. This this tank device, when we are using in the water, usually the long-term stability may not get. That's why we want to use it some water resistant and some other materials to choose to get more performance. And we also need to advance materials to the device for real for more robustness, uh, and also it is not degrading means long term years. And coming to cost and scalability of integration, finally the tank fabrication is simple, and scaling up to the integration of massive tank arrays. Um, this electrolysis is having storage capacity much be cost effective, and also this plays a very good vital role. Um, Coming to the conclusion, hydrogen is a critical molecule for decarbonization and long duration energy storage. And triboelectric nanogenerator offers a waste capture pathway, and which is having a low frequency mechanical energy, um, and that is waves and wind and motion, uh, to get the waste energy to electricity. And our research has successfully demonstrated to proof of concept of self-powered green hydrogen production. showing that the tank can effectively generated the voltage necessary to split water into hydrogen and oxygen, and this confirms the zero emission pathway. And by integrating these technologies, we are moving towards the energy system that is not only clean but self-powered, decentralized, and minimal external energy impact once it's deployed. Thank you for your attention. Thank you, sir. This is my presentation today.
Yeah, thank you, madam.
Um,
Participants, do you have any queries?
Sir, myself Abhishek Rajore, sir.
Yeah,
yes,
please.
Madam, you have said hydrogen is a critical. What you have said, madam? Hydrogen is a critical
it's not a
molecule.
crit.
You have said, na, ma'am.
Yes, it's a molecule. It's not a critical. It's hydrogen is a molecule.
Then you have said the hydrogen is a critical molecule. That what is the critical meaning? I want to
No,
say.
no, I didn't say critical. Maybe.
His
Sorry, I
slide is there,
didn't.
madam.
Okay, okay.
Last slide,
Didn't
madam. Conclusion slide.
conclusion. Okay. Uh, Hydrogen.
Hydrogen is the critical molecule for the
Ah, sorry. Maybe I wrote something, but it's just a molecule, but somewhere
for
I
that
missed.
reason only I have asked. Sorry for
Ah, okay, okay. It's my mistake actually. Sorry, sorry.
Can I interject?
Sorry, I
I
didn't.
think what the author actually meant is that hydrogen is a critical molecule for decarbonization perspective here.
I but yeah, it's
So, as in, hydrogen is not a critical molecule in a generic sense, but it is a critical molecule for decarbonization.
decarbonization. Yes, yes. CO2. Yes, yes.
Yeah, any more questions from other participants? Hello, any more questions from other participants? I hope no more questions. So we'll conclude this session. We extend our sincere gratitude to the Dr. Gokana Mohanrani for delivering an insightful and enriching expert talk
Uh, Thank you, sir.
on
Thank you.
emerging trends and innovations in hydrogen technology.
Yeah,
Madam, your presentation provided a comprehensive overview of the latest advancements
yeah.
and cutting edge research and transforming innovations shaping the future of hydrogen technology. The clarity with which you explained complex concepts, along with your ability to connect scientific understanding with real world applications, greatly enhances the learning experiences of our participants, madam. We
Thank you.
deeply appreciate the time, expertise, and thoughtful engagement you brought to this session. Your contribution has significantly added value to our FDP and inspiring a new perspectives for research and collaboration in the hydrogen domain. Thank you once again for your valuable support for sharing your expertise with us.
Thank you,
Thank you,
sir. Thank
madam.
thank you. Thank you all. Thank you.
Thank you, madam. So you can leave, madam. Otherwise, you can continue to the listen for other experts talk also.
Oh, okay, okay, sir. Thank you,
As you
sir.
wish, madam. As you
Okay,
wish.
sir. Thank you.
Okay. Okay. Yeah, participants, we have 15 more minutes time is there for next session. Next session speaker is also ready. If you all agrees, then we will start early, 15 minutes early. Otherwise, we'll take a 15 minutes break.
The break, sir.
Yeah, okay. We'll come back by 7:30.
Okay, sir.
I think, good evening, sir. Akash Sharma, sir.
Yes, sir, I'm ready, but I've
Yeah, you are
heard you,
ready.
and
Yeah.
that's okay.
Participants are requesting some 15 minutes break. We'll start exact by 7:30, sir.
Absolutely,
7:30,
sir.
sir.
Understood.
Yeah. Okay. Thank you very much, sir.